Hey everybody, back with standing waves. I just want to show you a couple quick things. First of all, when you get started on this, first thing it tells us that this length of rope is 12 meters. That helps us try and figure out what we're doing. But first step is how many bumps would all these things have? Okay, so basically one single harmonic with one bump. This would have two bumps, 3, 4, 5, and 6. Okay, so we can go ahead and try and figure out how many wavelengths each of those happen to be. So for one, that'd be a half a wavelength. 2 would be a full wavelength. 3 would be 1.5. 4 would be 2, 2.5, and then 3. Now, the reason I did it that way is because now it becomes relatively easy to figure out the wavelength in meters. Because, for example, if I know the length of the rope is 12 meters, and I have a single harmonic, that means I only have half. So 12 divided by half ends up giving me 24 meters. 12 divided by 1 is 12 meters. 12 divided by 1/2 actually ends up being 8 meters. 12 divided by 2 is 6 meters. 12 divided by 2.5 is 4.8 meters. And 12 divided by 3 is 4 meters. Okay, so fairly straightforward, nothing difficult there. Now, the next thing we want to use is we're going to calculate the speed for each one. Okay, here's our speed. Okay, here's our frequency or wavelength, and what we're going to calculate is frequency. So velocity divided by wavelength is going to equal frequency. Okay, so if we go ahead and plug some of these numbers in, let's go ahead and do this. 36 divided by 24 equals 1.5. That's going to be in hertz. So then 36 divided by 12 is 3 hertz. 36 divided by 8 is 4.5 hertz. Double check that one. 36 divided by 8, 4.5. 36 divided by 6 is 6. I'll get my units. 36 divided by 4.8, 7.5 hertz. And lastly, 36 divided by 4 is going to be 9 hertz. Now, you'll also notice a little bit of a pattern here. As we go up our harmonic, everything goes up by 1.5 each time. Fairly straightforward. It's easy to kind of see that pattern that takes place. The second part of this, I'm going to have you do on your own. But before that, what happens to the frequency as the wavelength increases? Okay. So, what's our frequency when we have 4 meters? Or when our wavelength is 4, and our frequency is 9. So what happens when we go up to 24 meters? Our frequency then becomes 1.5. So as wavelength goes up, what happens to frequency? It goes down. So as frequency goes up, what happens to wavelength? It decreases. Okay, so that they have an inverse relationship. That kind of makes sense to everybody? Hopefully it does. I want you to go ahead and do part E here on your own. And if you have any problems, feel free to shoot me a question on Remind, and we'll go from there. Thank you very much. Hope you have a great day. Enjoy.